In example 2, we're going to use the properties of parallelograms to solve for the variable, and then we'll justify our answer. Well, if we take a look, let me reset this on you. If we take a look here at this parallelogram, we want to see what we can conclude here. And one thing we know is that these angles here are congruent, and these angles here are also congruent. So that's going to be an x. This one's going to be 40. We also know that all four angles must add up to 360 degrees for any quadrilateral. You can form two triangles out of this thing. Each triangle would be 180, and there's two of them, so that's 360. Combined like terms, you've got 2x plus 80 now, 40 and 40 is equal to 360, so we'll subtract 80, and that leaves us with 280, divide by 2, and we find x to be 140. Well, if we're looking at this, if we want to justify, we'd want to write, and I'll just tell it to you right now, we know that these have to be supplementary also because they're same side interior angles if we only look at these two parallel lines and treat this line as a transversal. And so from our previous knowledge of parallel lines, we know that those are supplementary, and 140 and 40 is 80. Let's look at the next one. We've got 93 here. We know that these two angles are congruent, and actually these two angles here are going to be congruent as well. So x in this case is 93. Why? Well, we could state that as a property of a parallelogram, opposite angles are congruent, and it's really as simple as that for this one. There's nothing tricky about it. X has to be 93 for this to work out.